Okay, picture this. You're maybe right in the middle of filing your taxes online, late at night, or you're finally about to beat that final boss in a game you've sunk hours into. And then, boom, everything just freezes.
Yeah, that horrible moment.
Exactly. The app crashes, or maybe your internet connection just vanishes, or a whole service goes offline. What actually happens then? Is all that progress just gone? Or, can you somehow pick up right where you left off?
That's the million-dollar question, isn't it?
It really is. Welcome to the Deep Dive. Today we are peeling back the layers on something called recovery testing. And this isn't just like fixing a simple bug.
No, not all.
It's about the really sophisticated engineering that makes sure these incredibly complex digital systems we all rely on can actually recover from sudden, totally unexpected failures. Could be a tiny glitch, could be a massive outage.
Right, handling the unexpected.
So our mission for you today is to kind of shine a light on these invisible safety nets. We're going to unpack why recovery testing is even a thing, what happens, step by step when a system actually fails.
The whole cascade of events.
Yeah, and then dive into the intricate strategies companies use to get things back online. And crucially, how they test those recovery systems themselves to make sure they actually work when everything hits the fan.
Because a recovery plan that doesn't work is, well, it's useless.
Exactly. By the end, hopefully you'll see the digital world maybe a little differently.
So recovery testing, at its heart, it's really about validating a system's ability to bounce back. Bounce back from all sorts of disruptions. Could be software crashes, hardware going kaput, network outages, dropping connections.
Okay, so it's resilience then, not just does the feature work.
Precisely. It's resilience. It's not just about the code working perfectly when everything's fine. It's about its built-in ability to kind of self-heal, restore operations after being suddenly knocked offline.
Okay.
The main goal, really, is to ensure that software operations can continue or at least resume cleanly, even after some kind of disaster or if the data gets messed up.
And how does that actually happen, like technically?
Fundamentally, it means rolling the system back to a state where you know it was correct and consistent. Think like reliable snapshots or maybe using write-ahead logs. And then you carefully reprocess all the transactions right up to the exact point where it failed.
Ah, so you don't lose data, ideally.
That's the aim. No lost or corrupted data.
That makes sense. Sounds like a really big picture, system level kind of check, not like testing one button click. Is that why it's called non-functional testing?
You got it. That's a key difference. As a non-functional test, its focus isn't what the system does day to day, but how well it handles stress. Specifically, how robust it is, how well it recovers.
So less about the what, more about the how under pressure.
Exactly. It's less did the function run, and more can the whole setup survive a sudden shock and get back to business smoothly.
Okay, that helps clarify it. Can you maybe give us a couple of concrete examples? How would you actually test this stuff in the real world?
Sure. Imagine an application that's constantly streaming data, like, say, stock prices or sensor readings. A solid recovery test might involve literally yanking the network cable out, simulating a router failing or just a connection drop.
Right, pull the plug.
Pull the plug. Then you plug it back in and watch. Does it reconnect automatically? More importantly, does it figure out where it left off? Can it maybe even recover data packets that were, in transit when the connection broke?
Ah, okay.
Yeah.
That's seamless continuation.
That's the goal. Or think about your web browser. Maybe you've got like a dozen tabs open, spread across a few windows, doing important work.
Guilty. All the time.
Right. So a recovery test for the browser might involve forcing an abrupt system shutdown, just killing the power. Then, when you restart, you meticulously check. Did the browser bring back all those open sessions? Is your workspace preserved? Did you lose anything important?
That makes perfect sense. It's about minimizing that disruption for the user.
Exactly. That seamless continuation is key.
So, talking about those recovery mechanisms, it sounds incredibly complex. Once a system's up and running normally, what does that whole life cycle look like? From normal operation to failure and then back again.
Yeah, looking at the bigger picture, it usually follows like 5 distinct steps or phases.
Okay.
First, you got your normal operation, everything's humming along. Then step 2, some kind of disaster occurs. That's the trigger.
The trigger event.
Right. Step 3 is the actual disruption and the failure of the operation itself. Things stop working. Then, step 4, you hit this critical phase, disaster clearance. That's where the recovery process kicks in.
The cleanup crew arrives.
Sort of, yeah. And finally, step 5 is reconstruction. Rebuilding all the processes, restoring the information, getting the system back to its normal, stable state.
So when you say disaster occurrence, that's not necessarily like an earthquake, right? It could be internal stuff too.
Oh, absolutely. The triggers are super diverse. It could be a subtle software bug, maybe a bad input that crashes something deep inside,
Mhm.
or just straightforward a hardware failure. A disk dies, a power supply blows. But yeah, it can also be external physical events, fire, theft, floods, even things like a strike that takes key personnel offline.
Wow. Okay, and that third phase, the disruption phase, that sounds like where the real pain happens.
It really is. That's the point of maximum vulnerability. This phase, it almost always leads to, significant business losses.
I bet.
Yeah. Strained relationships with customers, missed opportunities because you're offline,
Yeah.
huge losses in man hours trying to fix things, and inevitably, yeah, financial damage and a hit to your reputation or goodwill.
And it's probably not just the immediate money lost, right? It's that trust thing.
Exactly. People often underestimate the damage to customer trust and the brand's reputation. That stuff is way harder and way more expensive to rebuild than just restoring the data itself.
So basically minimizing that pain, that disruption, it all comes down to being prepared before it happens.
100%. Sensible organizations, they put a huge emphasis on having a comprehensive disaster recovery plan. The goal is to make that painful phase as short and as painless as possible.
How do they do that?
It means having really robust backup plans in place, implementing risk mitigation processes way before any disaster hits, thinking about what could go wrong and how to prevent it or lessen the impact.
Right, proactive stuff.
Totally. And it also means very clearly designating who's in charge of recovery. A specific person, a dedicated team with really well-defined roles and responsibilities. So when disaster strikes, everyone knows exactly what to do for a fast, coordinated response.
And the reconstruction part, getting it all back together.
Yeah, that can be complex too. Sometimes it takes multiple attempts, multiple sessions to rebuild tricky things like configuration files or folder structures. That's where having really good documentation and well-practiced procedures becomes absolutely essential for getting it right. You can't just wing it.
Okay, so it's definitely not just reacting.
Yeah.
Companies are actively, architecting their comeback plan way in advance, designing the strategies.
Precisely. Recovery teams spend a lot of time developing very specific, tailored strategies for getting back critical code and data. And these strategies are unique to each organization, really driven by how critical their different systems are and what their specific infrastructure looks like.
So no one-size-fits-all plan.
Definitely not. There's no universal playbook here.
And when they're building these plans, especially around backups, what are the sort of key strategic choices they have to make?
They face some really fundamental questions, like, is one backup good enough? Or do we absolutely need multiple redundant copies?
Okay.
If we need multiple, should we keep them all in one place or spread them out geographically? Big difference there.
Right, risk spreading.
Exactly. Then are we talking online backups, hot backups, ready for immediate recovery? Or offline archives, cold storage for long-term safety but slower recovery? And how is the backup actually triggered? Is it automatic, based on a policy, or does someone have to manually kick it off?
Wow, yeah. Each of those must have pretty big implications for complexity, how fast you can recover, and definitely the cost.
Absolutely. Every single one of those strategic choices has its own distinct costs and needs specific resources. For instance, keeping multiple backups, especially if you spread them out geographically.
Yeah.
That takes significant physical resources, sometimes separate data centers, and often requires a whole separate team whose only job is managing and executing restoration.
A dedicated team just for recovery.
Sometimes, yes. Which leads to another big decision. Do you use your existing development team to handle recovery when needed? Or do you invest in that dedicated, independent restoration team?
That idea of an independent team, it seems to highlight something about dependency, right? What's the risk if your data, your code, your whole recovery hinges on one outside company or provider?
That's a massive vulnerability many organizations grapple with. Their entire ability to operate, to recover, can depend on a single third party. I mean, just look at the huge impact when a major cloud provider like Amazon AWS has a significant outage.
Right, things just stop working everywhere.
Exactly. An event like that can effectively shut down a huge chunk of the internet because so many services rely on it. It really hammers home why having independent restoration capabilities isn't just nice to have. It can be absolutely crucial for survival.
You can't have your lifeboat tied to the sinking ship, basically.
Precisely. You cannot afford for your recovery process to be blocked because the very provider you rely on is having its own disaster.
Okay, the planning sounds incredibly detailed. But, a plan on paper is one thing. How do companies actually do this? How do they execute and validate the recovery testing itself? It can't just be theory.
You're right, execution is everything. And the key here is simulating reality as closely as possible.
Right.
They have to build a test environment, a test bed, that mirrors the actual production setup almost perfectly. That means getting the interfaces right, the communication protocols, the specific firmware versions on hardware, the exact hardware models if possible, and of course the software versions.
So trying to make an identical twin of the real system.
As identical as feasible, yes. The goal is a complete validation in an identical configuration. Now look, exhaustive testing of every single possibility can be incredibly time-consuming and really expensive.
I can imagine.
But cutting corners on making the configuration identical or on doing a complete check, that's really risky. Thoroughness is non-negotiable if you want real confidence in your recovery.
And I guess doing these tests on the actual hardware you plan to use for restoration is vital, especially if it's maybe different from the original machine.
Oh, absolutely critical. It's especially important if you're restoring to a different machine than the one that created the backup. Some older backup systems, for example, are notoriously finicky.
How so?
They might demand that the hard drive you're restoring to has to be the exact same size, down to the byte, as the original drive the backup came from.
Seriously. That sounds like a nightmare with how fast hardware changes.
It is. It immediately brings up this huge challenge of obsolescence. Drive technology, storage tech, it evolves so rapidly. Old drives become unavailable, incompatible with new motherboards or controllers. It's a real problem.
So how do companies deal with that specific headache? You can't just keep stockpiles of ancient hard drives forever.
One really smart solution is using virtual machines, or VMs.
Virtualization?
Exactly. Companies like VMware and others, they specialize in creating virtual environments. These VMs can be configured to precisely mimic specific, even older hardware configurations.
Including things like exact disk sizes.
Yes, including exact disk sizes, specific network card types, disk controllers, all virtualized. This approach kind of insulates the recovery process from the constant churn of physical hardware going obsolete.
That's clever. Okay, what about online backup systems? Things like cloud backups. They often talk about being highly available, fault-tolerant. Are they exempt from this kind of rigorous testing?
Not at all. That's a common misconception. While it's true that most reputable online backup providers use very robust storage on their end, things like redundant arrays, multiple copies, which protects against, say, a single disk failing on their side.
Why, they handle that part.
They handle their storage reliability, yes. But it's still absolutely essential for you, the customer, to rigorously test the restore side of their service.
What do you mean by the restore side?
Making sure you can actually get your data back when you need it. You need to test. Does the restore process actually work? Are there any security hurdles? Is the encryption-decryption functioning flawlessly during retrieval? Are there performance bottlenecks when you try to pull large amounts of data back?
Ah, I see. So just because it's backed up doesn't mean retrieving it is guaranteed or easy.
Exactly. The restore is the moment of truth for any backup system, online or offline. You have to test it.
Okay, so let's fast forward. The disaster happened, the recovery plan was activated, the systems or data have been restored. How do organizations know for sure that everything is actually back, that it's all there working correctly, just like it was?
Well, for larger corporations, a pretty standard practice is to bring in independent auditors.
Outside experts.
Yeah, third parties. They
Yeah.
come in periodically and conduct formal recovery test exercises. They run through scenarios, check the procedures, verify the results. It gives the company an unbiased validation that their recovery capabilities are actually effective.
It sounds thorough, but probably expensive too.
It is. It's a significant investment. And honestly, the cost of maintaining that kind of comprehensive, independently audited disaster recovery plan, it can often be just too expensive, prohibitive for smaller businesses.
So what do smaller businesses typically do?
They might have to rely more on, the basics. Regular data backups, maybe storing copies off-site, simpler cloud backup solutions, which is definitely better than nothing. But it often falls short of that fully tested, comprehensive DR plan the big guys have.
And that creates a gap, a vulnerability.
It does. It's a significant vulnerability for those smaller businesses, and you could argue by extension for the larger economy or ecosystem they're part of.
Right. So, okay, let's get practical then. When you talk about restoring your progress, maybe those tax files or your game saves once the files and folders are supposedly restored by whatever method, How do they actually check? What are the steps to validate it's really all there and usable?
It involves running through a pretty rigorous checklist, usually.
Like what?
Well, they might start by, say, renaming any potentially corrupted folders that were left behind, just to make sure the system is forced to use the newly restored version.
Okay, makes sense.
Then, they'll often meticulously count the number of files in the restored directories and compare that count against records from before the failure or against the backup logs to confirm everything came back. Completeness check.
Gotcha. Counting files.
Yep. But just having the files isn't enough. The crucial part is opening them. They'll systematically try to open a wide variety of file types, pictures, music files like MP3s, complex documents, spreadsheets, databases, some really large files, some tiny ones.
Using the normal apps.
Using their normal native applications. And they don't just check if it opens, they check if you can actually browse the content, if you can edit it, if you can save updates. Full functionality.
Okay, that's thorough.
And many operating systems also provide powerful utility programs specifically designed to compare files or even entire directories bit by bit. That adds another layer, an automated way to verify data integrity and make sure nothing got subtly corrupted during the restore.
Wow. Okay, so pulling this all together then, what's the big takeaway from this deep dive into recovery testing?
I think the main thing is realizing just how much meticulous, systematic effort goes on behind the scenes. It's this hidden foundation under our digital lives.
Right.
These efforts, this testing, it's the reason why these incredibly complex digital systems, everything from, your irreplaceable family photos to the massive global internet services we use every single day, why they can often, against pretty incredible odds, recover from what seem like catastrophic failures.
It's like this silent guardian then, protecting our data, keeping things running.
That's a great way to put it, a silent guardian of data integrity and operational continuity.
So, thinking about all that, it leaves us with maybe a final thought to chew on. Given how complex this is, how much expertise it takes, and as you said, the significant cost involved in doing this recovery testing and disaster planning really rigorously, what happens in the gaps? What are the sort of maybe overlooked societal vulnerabilities or perhaps even unexpected opportunities that might pop up because smaller businesses or maybe critical public services that are under-resourced simply can't afford to implement these kinds of really comprehensive measures?
That's a really potent question.
How could those gaps, that lack of resilience in some corners, ripple out and potentially impact you, the listener, directly, maybe in ways you haven't even considered?
Yeah.
Something to think about.